Okay, so the last one is the heat of a reaction. So I have 2 moles of hydrogen peroxide, and it decomposes or breaks down into oxygen, 1 mole, and 2 moles of water. Oxygen just occurs naturally, and it has 0 amount of heat, okay, or delta H, because it's just a free occurring element. Now, if I look at this enthalpy, delta H is the heat of the products minus the heat of the reactants. So we know that this is the product side, and this is the reactant side. Now, notice that this says kilojoules per mole. So if we have more than 1 mole, we've got to remember what to do. So the heat of the products, oxygen doesn't have anything to worry about. I have 2 moles of water. Each mole of water is going to release 285.83 kilojoules per mole. So there's my product, my heat of the products. And then my reactant has 2 moles of H2O2. So I'm going to write that down as 2 moles. And each mole of H2O2 is a negative 191.17 kilojoules per mole. Moles will cancel. So I'm going to multiply that times that. And when I multiply that times that, I'm going to get 571.66 kilojoules, but it's a negative. And then I'm going to multiply 2 times negative 191, and I'm going to get a negative 382.34 kilojoules. Now I'm going to take that negative and subtract it from the, or take this and subtract them. So that's the same thing as a positive sign in there. So my answer is going to be delta H is equal to negative 189.32. Negative 189.32 kilojoules. And remember, when you add or subtract and you're looking at significant digits, you always go to what amount of numbers you had beyond the decimal, or the least amount. There's 2 there and 2 there, so I want to make sure it's recorded to 2, and it is. Then they want to know, is this reaction endothermic or exothermic? Well, it came out negative, which means that heat is given off, so negative sign indicates heat is given off. So delta H, or this reaction I should say, is an exothermic. So reaction is exothermic. Okay. All right, then we want to go on to this next one. Last one. And it says ethane undergoes combustion according to this following reaction. So I need to do delta H equals heat of the products minus heat of the reactants. So these are my products. These are my reactants. So I have 6 moles of H2O, and H2O is negative 285.83 kilojoules per mole. And then I have 1 more reactant, and it's 4 moles of CO2. I'm sorry, I have 1 more product, and that product is CO2. I think I said I have 1 more reactant. So negative 393.51. And I did that math, and I think I got, if I wrote it down, a negative 1714.98 kilojoules. And then for CO2, I got negative 1574.04 kilojoules. So there's my products. Now I need to do my reactants. Heat of the reactants is going to be 2 moles of negative 83.8 kilojoules per mole. So that delta H is going to be a negative 167.6 kilojoules. So I want to do delta H is the products. So I need to add negative 1714.98 plus a negative 1574.04. And those are in kilojoules, which I should put the units there. There's my heat of my products. My reactants need to be subtracted from that. The heat of the reactants is negative 167.6 kilojoules. So those negative values plus a negative gives me, or minus a negative gives me a plus sign there. So my delta H is going to be, if I get this correct, let me stop for a minute and make sure I got it correct. Okay, so when I did my math, I wound up with a negative 3121.42 kilojoules. And again, that negative sign right there tells me that it's exothermic. Since delta H is negative. And also, if you look at it, it says it's ethane is undergoing combustion. Combustion means to burn. Usually when we burn things, heat is given off, so that also is a big clue that it's exothermic. Okay, please be certain that you study.